practice, we call this practice 1 because we're talking about binomial experiments. Or if you want to continue on with the practices, this will be considered practice 10 because the binomial theorem was actually stopped with practice 9. So here, there's a question that's going on here, and I'm going to help you through a little bit of it, and then I'm going to release you to do the rest of it by yourself. So this says that about 70% of the questions created by a random computer test generator for a science program are multiple choice. 70% multiple choice. The rest are true, false, or matching. What is the probability that at least 3 of the 5 questions generated for a short quiz are multiple choice? So there's 2 scenarios going on. And what are those 2 scenarios? Okay, multiple choice is one, and then the other ones are the other. So true, false, matching are the other one. So it's not multiple choice, then true, false, and then matching. It's multiple choice, and then true, false, matching. All that goes together. So those are 2 scenarios. Multiple choice, and you can say not multiple choice. Multiple choice and not multiple choice. Now here, there's m plus n because we're saying multiple choice and not. So I said m plus n. But if you want to use something else, m and t or something of that sort, that's fine too. Just remember what m means and what t means. But how many questions are there in all? So 3 out of 5, so it means there's 5 questions in all. So it means that's why we had 5 right here, because that's the total number of questions. Okay, and they want to know, and this part here is important, they want to know at least 3 out of 5. So does that mean at least 3 out of 5, I believe I wrote this last part down. That means 3 or more. Sorry, I didn't mean to show that part yet. That means 3 or more multiple choice. Multiple choice. So behind this, right, should have the word choice. Multiple choice. There we go. So with that, we're not talking about the not multiple choice. We're talking about 3 or more multiple choice. So be careful when you write this that you're dealing with the m being 3 or more and not the n. Don't just copy what we did on the last problem. Be like, oh, that's what we did on the last problem on the example, so that's it. No, we're talking about multiple choice, so it means that, remember, that is m. And then they give you a probability up here of multiple choice. You have to figure out the probability of the not multiple choice, and then do all that from there. And again, if on this problem, if you have questions on this practice, let me know, call me over, and I'll help you out. All right, so have fun.